Hello students, have a nice day. Good morning to all. In today's class, we are going to revise second volume, 9th lesson, electrochemistry in our terminal examination. Okay, we have 7 lessons for our terminal examination. The pattern is choose the correct answer 15 marks, 2 marks 8, 3 marks 8, 5 marks 5. Okay, let us start now. In this chapter, what is conductivity of electrolytic solutions? So what is conductivity of electrolytic solutions? A conductive cell consists of 2 electrodes immersed in electrolytic solution. It obeys Ohm's law like metallic conductor, that is at constant temperature the current flowing through a cell I is directly proportional to the voltage across the cell V, that is I is directly proportional to V, or I equal to V by R equal to V by E equal to IR. So here the R is a resistance of the solution in ohms. Okay, this is a conductivity of cell. The next one, resistivity. The resistivity symbol is a rho. So what is resistivity? It may be asked in sometime it may ask in the formula of resistivity or definition of resistivity. You can write the definition and formula. So what is the formula of the resistivity? R equal to rho L by A. This is a resistivity formula. Okay. The next one, conductivity. So conductivity, what is meant by conductivity? The reciprocal of the resistance gives the conductance of electrolytic solution. It is called as a conductivity. The SI unit of conductance is a Simon S. The formula is C equal to I by R. That is C equal to 1 by P equal to A into L. Okay. The next one, molar conductivity. So what is molar conductivity? Molar conductivity means the solution of different concentration of different number of electron ions in given volume of solution. They have different specific conductor. New quantity called as a molar conductivity was introduced. Okay. So the formula of molar conductivity is K kappa into V. So we know that molarity equal to number of moles of solute N by volume of the solution V. So therefore the solution containing 1 mole of solute 1 by M. Okay. The next one, equivalent conductance. So define equivalent conductance means the conductance of the V of electrolyte solution containing 1 gram of equivalent of electrolyte in a conductivity cell, which are electrodes are 1 meter apart. The formula is K, that is copper into 10 power minus 3 gram equivalent meter cube into N. So K is that is copper, is represent K, the specific conductance, and N is the concentration of the electrolytic solution expressed in a normality. The next question, it may be asked, what are the factors affecting the electrolytic conductance? So what are the factors means it may be asked in the 3 marks or 2 mark question. So it's a very important. What are the factors means the first factor is solvent of the higher dielectric constant show high conductance in a solution. Then second one, the conductivity is increased with the decrease in viscosity. If the temperature of the electrolyte solution increases, the conductance also increases. Increase in temperature means the increase the kinetic energy of the ion. The decrease the force of attraction is decreases. So between the opposite charge ion, so hence conductivity also increases. So molar conductance of solution increases means the solution, that is the dilution also increases, because the strong electrolyte, you know the meaning of strong electrolyte and weak electrolyte. Strong electrolyte means it's a completely dissociation. Strong electrolyte, the interionic force of attraction decrease with the dilution. For weak electrolyte, the degree of dissociation, the acetic acid is a weak electrolyte, the degree of dissociation increases with the dilution. So these are the factors affecting the electrolytic conductance. The next question is measurement of conductivity of an ionic solution. It may be asked in Wheatstone bridge circuit. So okay, so what is Wheatstone bridge means? The principle of Wheatstone means simply the conductivity of electrolytic solution determined using the Wheatstone bridge arrangement, in which one resistance is replaced by conductivity cell filled with electrolytic solution of the unknown conductivity. The specific resistance of metallic wire, the DC power supply is used. So the power DC current through the conductive cell, it will lead to the electrolysis of the solution taken in the cell. So AC current is used for the measurement to prevent the electrolysis. The formula for the balance conditions, the variable resistance S is adjusted until the bridge is balanced, and the solution, there are no current flow through the detector. So balance the condition, P by Q equal to R by S. Therefore R equal to P by Q into S. P by Q into S. So the resistance of the electrolyte solution R is calculated from the known resistance value, that is P, Q are measured, S value the under balance condition. The next question, conductivity of that is a variation of molar conductivity with a concentration. So variation means we can use the various concentration level, the molar conductance for the various elements. So the above based on the above equation we can search result. The Coleridge law deduce the empirical relationship between molar conductance and concentration of the electrolyte, that is C. So this is the equation. This is the equation for the this one is the equation for the variation of molar conductance with the concentration. So the above equation, the straight line from y equal to mx plus c, hence the plot of m versus root of c, we get a straight line, the negative slope of minus k, and the intercept is a y, where inverted v m is called as a limiting molar conductivity, that is molar conductance approach limiting value in very dilute solution. Okay, the next question is the next one, D by Huckel answer the equation. This is a deleted one. The next important 5 mark is, the next one is Coleridge law. So what is Coleridge law? The Coleridge law means the limiting molar conductance, the basis for Coleridge law. At the statement for the Coleridge law, at infinite dilution, the limiting molar conductivity of electrons equal to sum of the limiting molar conductance of constituents ions. That means molar conductivity is due to the independent migration of cation in one direction and anion in a opposite direction. For example, the Coleridge law, we can take the example NaCl. So the Na plus Cl minus. In general, according to Coleridge law, the molar conductivity at infinite dilution for electrolyte represent the formula AB, that is Ax by is given below. So similar to the NaCl. Then application of Coleridge law, the first one is the calculation of molar conductance at infinite dilution of weak electrolyte. So weak electrolyte means we contain acetic acid, calculated using experiment to determine the molar conductivity of strong electrolyte HCl, NaCl and sodium acetate. Then second one, the calculation of degree of dissociation of weak electrolyte. Then third one, the calculation of solubility of strongly soluble salts. So these are the applications of Coleridge law. The next one, electrochemical cells, galvanic cells, these are reduced portion. Okay, the next one, galvanic cell notation. I think galvanic cell notation. So page number 47. Okay, galvanic cell notation. So we can write some cell representative equations. Okay, so in based on the galvanic cell notation. So the what is phase boundary, what is the left side, what is the right side of the cell. In galvanic cell is represent cell diagram. For example, Daniel cell represent Zn Cu2 plus copper. Okay, so the above notation, the single vertical bar, that is this one, the single vertical bar is represent phase boundary. Then double vertical line, that is this one, is a salt bridge. The anode off cell is written on the left side of the salt bridge. The cathode is written on the off side of the right, off cell on a right side. Okay, so anode means left hand side, cathode means right hand side. The next, the anode and cathode written the extreme left and right, extremely right respectively. The aim of the cell is written the right side after a cell diagram. After a cell diagram. The next one, the this example. This diagram is a example for the cell galvanic cell notation. The next one, measurement of electrode potential, that is represent She. She means standard hydrogen electrode. Okay, so the what is She? She means The overall redox reaction can be considered as a sum of two ox reaction, that is oxidation and reduction. So the EMF cell can be considered the sum of the electrode potential at the cathode and the anode. So here the anode plus cathode, the represent oxidation, that is anode represent oxidation potential and the cathode represent reduction potential at a cathode. Okay. So it is impossible to measure the EM of single electrode, but we can measure the potential difference between the two electrode. Two electrode means cathode and anode using a voltmeter. If we know the EM of any one of the electrode which constitute the cell, we can calculate from other electrode from the measure of the EMF cell using the equation. So it is called as a electrode because EMF is known as a standard hydrogen electrode, that is a She. Okay. It has been assigned arbitrary EM of exactly 0 volt. So it consists of the platinum electrode connected to 1 mm of HCl solution and 1 atmospheric pressure of hydrogen gas. The hydrogen gas is a bubble out to the solution of the 25 degrees Celsius. So this is the cathode as well as the She can act as a both cathode as well as the anode. So the off reaction of the cathode reaction cell and anode reaction cell. Then examples for the standard electrode hydrogen electrode potential. Okay. So the next one, thermodynamic cell of reactions. It is a 5 marks question. So in N is a number of moles, that is thermodynamic cell reaction means the chemical energy is converted into electric energy. So the electric energy produced the cell is equal to product of total charge of the electrode, the EM of the cell, which drive this electrode between the electrodes. So where N is the number of moles of electron exchange between oxidizing and reducing agent in overall cell reaction. The electric energy produced by the cell is given by below. Electric energy equal to charge of N mole of electrons into each cell. So charge of 1 mole of electrons is 1 Faraday. Then 1 N mole of electrons N Faraday equal to electric energy equal to NF E cell. The next, the second, the minus sign introduced, indicate the work done by the system on the surroundings. So we know the second law of thermodynamic, the maximum work done by the system is equal to the Gibbs free energy. So the equation is W max equal to del G. So we can rearrange del G equal to NF E cell. Okay. Then this reaction is a spontaneous reactions. The del should be negative, del G should be negative, then E cell should be positive to get the negative del G value. So that is standard condition, del G not equal to minus NF E not cell. Okay, this is a thermodynamic cell reaction. The next question is an important question. So 5 mark question, Nernst equation. So it may be asked in the right Nernst equation. So the Nernst reaction, the concentration of the species in electrochemical concert, it is considered electrochemical cells which in overall redox reaction. So A plus B gives us C plus D. So we can write the reaction quotient form C product by reactant. So this is a product, then this one is a reactant. So we can write product by reactant. We already learned del G equal to del G plus RT ln Q. RT ln Q. So the Gibbs energy related to the EM of the cell. Okay. The next one, the substitute the values Q from the equation 9.28 and 9.29. We get a NFC equal to NFD RT ln product by reactant. So this is a Nernst equation. Okay. The next one, the state Faraday's first law and second law. It may be asked a 2 marks question or 3 marks question. You can write what is state, what is Faraday first law and what is Faraday second law. Faraday first law means the mass of the substance liberated at the electrode during electrolysis is directly proportional to the quantity of the charge, that is Q, passed through the cell. The equation is a M is directly proportional to the Q. Okay. Then second law means the second law of Faraday is, this is a second law of Faraday. When the sum of claimed quantity of charge is passed through the solution of different electrode, the amount of substance liberated respective electrode is directly proportional to the electrochemical equivalence. So this is a second law of Faraday's. Okay, students, I hope you understand the revision part. Thank you so much.